This section is basically teaching us how to find the answers by hand when there are numbers on the integral. So the definite integrals. This section actually has a couple topics, but I pretty much thought that today I would mainly try to focus only on finding the answers to definite integrals. It's theoretically called the fundamental theorem of calculus. Well, this one says part 2. I was always told and seen in other textbooks that they just called it the second fundamental theorem of calc. So you'll probably hear it different ways. It's basically just telling you how to find answers to this, though. You very possibly can read it. Like, the notation on this one isn't that bad. Some of our calc formulas have a crazy amount of notation, so you have to try to translate it. Who should we start with? Laura, let's let you pick the person since you went last yesterday, I think. Parker? You got chosen. Didn't you go yesterday too, though? I don't know. Okay. Do you remember what the capital F traditionally stands for? Oh, this is a bad first pick. Okay, you pick the next person. We need somebody to remember this before we can go on. Noah. You said it too quick, but I think you said it right. The antiderivative, is that what you're saying?
Like the derivative of f is the big F. Or no, the
Yeah, okay, you're saying it backwards, right.
yeah.
Capital F is the integral of little f, or the antiderivative of regular f. So traditionally, whenever you see a italicized lowercase f, it's just going to represent a function. If you ever see the italicized capital F, it traditionally stands for the integrated answer of regular f. So what this is saying, if we're trying to do the integral from a to b of a function, capital F represents the integrated answer, and then we're going to plug in the top number minus plug in the bottom number. All right, I'll go shut my door. That looks like some work's going to go on. Somebody came once already to try to fix the water fountain to see what parts they needed to order. But that was about 2 months ago. Yeah. Do you know the original plan was to have one of those water fountains in every pod, like all around the school? I don't know what happened to that plan. Now we have, I think there's only 3 of them total or something, isn't there? Is there upper yellow, lower blue, and cafeteria? You guys look like you have no idea what I'm talking about. Have you never used the water fountains? Yeah. I'm a little worried. Do you guys just only bring like bottled water and drinks from home or what? Wow. We have a spoiled class. Okay, do you want me to repeat what this represents? Okay. If you are integrating from A to B, you are going to use the integrated answer, plug in the top number, plug in the bottom number, and then subtract them. The biggest mistake most students make, which I kind of get, is they will forget to integrate before they start plugging in the numbers. So like when I'm correcting tests and things, that's traditionally the most common mistake I'll run into. You basically integrate first, and then you're either going to write a plus C or you're going to subtract the answers. Now, after a while, this formula kind of takes on different versions. Like after a while, you may know this answer, and you may know this answer, and you'll be asked to figure out this answer. So just letting you know that this formula, even though at its basics, is just telling you to integrate, plug in the numbers, and subtract. But depending on how the problem is presented to you, you might know you're not, how should I phrase that? There's three things up there. There's the integral, there's the two integrated answers subtracted. You're going to be given two of them to figure out the third. Okay, let's try to do one here. Noah, who are you calling on?
Carol.
Okay, so what I was hoping you could help me do first, Caroline, is integrate x squared minus 3. I 100% see your mouth moving without hearing a word. Let's just treat me like I'm 90 because I basically feel like it. I'm deaf and blind, so.
X cubed divided by 3 minus 3x.
Perfect. Nope. I'll get to that part, but you're right. I'm guessing a lot of you are at the point where you no longer need to write the separated integrals, and you probably no longer need to write like individual terms. You basically just do it in your head probably from the get-go. You are fully allowed to do that. Like, you don't have to show the work in between. If you want to separate the work for your own benefit, you can. But just letting you know, you're 100% allowed to go right to this. Now, the way that they write this notation, instead of writing a plus C, you are going to write a bar at the end of it with the two numbers. That's probably the most common notation you'll run into. This bar represents the fact that you already integrated it. That's why you no longer write that little symbol. But this symbol means that we still have to plug in the numbers. So then now we're going to plug 2 in to get an answer. So 2 cubed would be 8. So we'd have 8 thirds minus 6. That's the answer for plugging in 2. Then I'm going to subtract the answer for plugging in 1, which would be 1/3 minus 3. I would fully recommend you write it like this all the time, like in parentheses or brackets, because you're going to find that you'll traditionally have a bunch of terms. And so when you're plugging in the numbers, the fact that we're always subtracting always means we have to distribute that negative sign. And so I've seen it far too many times over the years that somebody trying to just plug all the numbers in their head, they're going to get one of these plus or minus signs wrong. So if you write it like this, you'll at least not make a mental error. Okay, so I've got 8 thirds minus 1/3, so we've got 7 thirds. That didn't help much at all. -6 plus 3 would be -3. So I've got 7 thirds minus 3, which -2 thirds. Okay. Now, just for this first problem, let's verify this answer on the calculator. We generally won't need to after this. So this is the same type of problem. We were trying to find the area under the curve. But on this one, we're doing it by hand. That's not the calculator. That's the calculator. I'm just going to do the graphing one just to show you the area, how it ties together. But you don't need to do the graphing method. You could just type in the integral. So was it 1 to 3? 1 to 2. Okay, thank you. I'm going to do the integral, number 7, lower limit of 1, upper limit of 2, and the answer was negative 2/3. So we've got negative 0.67 down here. So essentially, we started off by learning visually that it stands for the area between the curve and the x-axis. But we shouldn't need to do that anymore. I mean, you can always use your calculator to verify things, make sure you're doing things right, whatever. But we probably won't. It's going to be, honestly, it's quicker to do this anyway. But okay, are we feeling right about the first problem? Caroline? Are you picking Emily just to be mean? Oh. Who'd you pick? Oh, okay. Do you think he even knows he got picked yet? You got chosen, apparently. Do you think you could help me just go through and figure out the answer to this, however you want to do it?
So for the let me finish can I finish all my paper and then finish studying?
Sure. I'm going to write this part down because I know he's probably doing this first anyway.
So it's like the integral 2x to the power of 3 over 2.
Oh, you integrated it. Okay, so what did you get?
2x to the power of 3 over 2.
Like that?
Yeah.
Okay, I didn't know if you meant the power was 3 over 2 or if the whole thing was over 2. Okay, so yeah, so you add 1 to the power, and then that'll become 3 halves, and then you need to multiply by 2/3. The 3's cancel out. And we're going to put a bar at the end to signify 1 to 4.
And then it's like 16 minus.
Back up. Did you use your calculator to put that in?
Yeah.
What are you doing?
It's like faster, so I can tell you the answer.
So you only did it because you felt like you were under pressure?
Yeah.
I feel like that's a lie, but okay.
And then
I'll redo it because I guarantee some people need me to remind them how to calculate 3 halves. Is that true? Okay. I'm going to plug 4 in first for x. So 4 to the 3 halves. The 2 on the bottom means root. So you traditionally do that first. So the square root of 4 is 2. The 3 on the top means cubed. So 2 cubed would be 8 times the 2 is 16. So I'll repeat that one. 4 square root first, 2. Cubed would be 8. 1 is nice and easy because it's still 1. Now, I'm positive somebody will have this question at some point. Somebody's going to ask, how come we don't write plus c when we're doing a definite integral? And it's a very valid question. It actually has a pretty simple answer. Is because the plus c won't affect the answer at all. So let me do, you can just watch this one if you want, but let's say we'll do something pretty straightforward like 2 to 3 of 2x dx. On this example, I'll write the plus c. So if I integrate 2x, I get x squared plus c, and I'm going to evaluate it from 2 to 3. If I plug in 3 first, I get 9 plus c. If I plug in 2 next, I get 4 plus c. So if you write the plus c, it will always cancel itself out no matter what. So You're fully allowed to write plus C for every single problem if you want to. AP does not make you write plus C on a definite integral because it will always cancel out. So that's the main reason on our examples that we've been doing, I haven't had you write plus C. The downside to that is it makes it hard to remember to write plus C when you're doing an indefinite integral without the numbers. So if you feel like you're a person that's going to forget the plus C later, you can write plus C on every problem if you want, and it's still correct. You would never have that marked wrong. John Woo, you went, right? Who's going to help me with the next one? Oh, are you going up there? Oh, dang. Okay. Do you want to? Dang. All right. Wait, are you going to stop and write the whole problem down now, too? I want to know your thought process. I shouldn't say I do. I think everybody in here wants to know how to do this step by step. I'll do the work for you. You tell me what to do. Oh, how come? I don't like foiling. How come I have to do that? Well, you're not wrong, but that didn't give any kind of reason at all. It's because foiling it will cause them all to be individual terms so that the power would be on an individual variable instead of a whole parentheses. So we'd have 4x squared plus 4x plus what? Let's pretend I foiled better. 4x squared minus 4x plus 1. Okay, squared divided by 2, yep. X. If I want to write a plus C, I can. Otherwise, I'm going to immediately go to negative 1 to 1. Okay. I don't really have much room here, though. Plugging in 1 would give me 4/3 minus 2 plus 1. That's not great. I can't do that in my head. Okay. Plugging in negative 1. What did you say it was? 1/3? Okay. Plugging in negative 1 would give me negative 4/3 minus 2 minus 1. So 8/3 minus 2 plus 1 is negative 1. Plus 2 would be 1. Plus 1 would be 3. 17/3. Pretty sure. Do your best to practice mental math on this whole part. Well, you got to take half the AP test without a calculator. And guaranteed, these are the types of questions you get on the non-calculator portion. The calculator portion, they immediately change it to equations that you can't integrate by hand and numbers that you have to figure out ahead of time. So you basically resort to the calculator when there's no way to do it by hand. So practicing mental math will help you out. I know you hate it. Are we feeling okay about that problem? Did I add it wrong? That's 100% possible if I have the answer wrong.
I thought it was 14.
Is the 8/3 wrong? Oh, is it plus 2? Negative 2 plus 1 is negative 1. Negative 1 plus 2 would be positive 1. Oh, yeah. I think I saw the 2 and then in my head made it a 2. There. Psh, never happened. Okay, do you guys want me to practice more difficult ones with you or anything? F? I was thinking E looked harder to you guys than F, but I could be wrong. I don't care if we do any more or not. This is the topic I wanted us to practice today. I wanted to go over the first fundamental theorem of calc tomorrow, but I wanted you to do definite integrals first because it kind of rely on each other. I think it's the next section, maybe. It's once we get to use substitution, like reverse chain rule. Okay, maybe what I'll do with you guys is go over how to write this for integration, and I'll let you do the actual integration on your own, which I think you're pretty good at that part. Okay, root 2 over x. In my mind, I need this x to be kind of on its own, so the first thing I would do is separate them like this. Because I need the x separate than the multiplier. And then having a root x on the bottom is the same thing as writing x to the negative 1/2 on top. So this one, you could take the root 2 out if it bothered you, and then integrate x to the negative 1/2 dx. F, you should be getting a little bit better at this in your head. I have x to the first on the power, x to the first on the top of the fraction. I have x to the 1/2 on the bottom. So if I subtract their powers because they're being divided, it would turn into a positive 1/2 power on top. And then this root x on the regular 2 would just come up as a negative 1/2. Basically, when you have a single term on the bottom, you can apply it to both terms on top. And if you want to bring it up as a multiplier and multiply it out, it gives you the same answer. So it's just kind of however your brain feels is easiest. A lot of this is going to be all about being able to rewrite it so that it fits the things we know. And we basically know the power rule and 6 different trig integrations. And so our goal is just to rewrite everything so it fits those things. Okay, in the homework itself, if I were you, I haven't even looked to see what numbers they are. It's going to be scattered around. Only try to do the problems that are set up as definite integrals. I want you guys to have practice doing the integration, subtracting the answers. The more you practice it, the more ingrained it is in your brain, so it's far less to think about when you run into them. So that's what I'd like you guys to practice here for the last half.